Good day, everyone. I'd like to welcome you to the GTAC Tech Talk webinar on Sharp camera hardware and software configuration. My name is Derek. I'm a technical support representative with Genetec, and I'll be your host for today's webinar. We also have other members of the Genetec Technical Assistance Center standing by to answer your questions during the webinar. Just type them in the questions section of the GoToWebinar console, and someone will get back to you shortly. If there are any questions that we cannot answer in the time we have today, we'll be sure to send you an email with your answer. We'll also be posting the questions and answers from today's session in the Genetec Technical Assistance Portal forums under the GTAC Tech Talk section. If you have any additional comments or questions on the webinar or the GTAC Tech Talk webinar series in general, you can post those here as well. Also to be found on the GTAP are the videos from previous webinars. Just go to Tools and then Videos, and then click on the GTAC Tech Talk section over here. You can either watch a streamed video in your web browser by clicking on this icon here, or you can download the video in WMV format for viewing offline by clicking on the second icon here. If you want to be kept up to date on the latest additions to the Genetec Technical Assistance Portal, you can log into the GTAP, go to the My Account section, and click on Email and Notifications. From the notifications screen down here, you can check the boxes of the subjects you're interested in, and select how often you'd like to be alerted to additions to those subjects. In order to be able to put a checkbox next to a subject, the frequency will have to be set to daily or weekly. If you set it to never, it's going to gray out the options below it. You can also edit your subscription to our 2 Genetec newsletters in the email subscription section above that. And don't forget to hit the Submit button on the bottom to save your changes. So before we go right into the subject, I'd just like to take a minute to go over the topics that we'll be covering today. Now, first off, we'll take a look at the Sharp product range and go over the differences between the different models in our family of Sharp products. The next subject will be our plate reader server, which is the software that runs on all of our AutoView hardware. After that, we'll go over the configuration of the software on the Sharp cameras, and then the integration with our Genetec software, in particular with the Security Center system. Now, the last section we'll be going over is any limitations there may be with the system, and we'll take a look at some helpful tips for supporting the units. The webinar should take around 45 minutes, and as I previously mentioned, we'll leave the webinar open for questions for about another 10 minutes or so after that. Okay, so first things first, let's take a look at the 3 different types of Sharp systems that we have available in our license plate recognition family. The first model is our classic Sharp here, which is known as the Sharp XGA. This is our most common unit out there and is very versatile, as you can use this for both fixed and mobile installations. So just to clear up what that means, a fixed Sharp would be one that is mounted on a pole, building, or other non-moving location. A Sharp that's being used for mobile purposes would be mounted on a vehicle such as a police car. The other nice thing about the Sharp XGA is it can be portable. If you have a portable kit, you can easily install this on a vehicle and be up and running in 5 minutes. Similar to our classic Sharp, we have the Sharp EX. The other common name we use for this model is the blind Sharp, since it has no cameras on the actual unit. This unit is for fixed systems only, and is commonly used to meet specific space and location requirements. If you don't have room for a regular Sharp, you can have this unit stored somewhere out of the way, and have cables run to your independent cameras. Now, we'll go over this more in a few minutes. The important thing to remember with this unit it's that it's a processing unit only. And the last system we have is called the Sharp X. This system is used for mobile systems only, and has a few major differences between the classic Sharp XGA. The first thing you'll notice here is the camera size. This is one of the smallest license plate recognition cameras on the market, making it very hard to detect. In cases where it's mounted alongside the light rack on top of a police car, it's practically invisible unless you're standing right next to it. This system is also very scalable. You can have up to 6 cameras on a vehicle without any decrease in performance. The other main difference between the classic Sharp and the Sharp X is that the processing is done on a separate unit, which can be stored in the trunk or other part of the vehicle. Each processing unit can handle 2 cameras, so if you want to add more cameras, you'll have to add more processing units. If you add more cameras, you won't have a decrease in performance, just a decrease in trunk space. Now, just a side note that both the Sharp XGA and the Sharp X can be ordered with many variations of camera lenses and illumination to fit any need. So let's take a closer look at each, starting with our Sharp EX, also known as the blind Sharp. Basically, it's like a classic Sharp, except we've removed the front of the unit where we have the lenses and illumination. Instead, we've replaced it with 2 BNC connectors, which can be used with any analog cameras, either NTSC or PAL. The only limitation is that the cameras must both be the same model if you'll be reading plates with both of them. We've done some tests with various analog cameras, but we don't have a supported hardware list for the cameras that can be attached to a Sharp EX. Now let's take a look at our classic Sharp XGA unit. Typically, if someone mentions a Sharp camera, we're usually referring to this one, since it's our most commonly used LPR unit. There are 3 versions of the Sharp XGA, 1.0, 1.5, and our current version 2.0. On the hardware side, there isn't a lot of difference between the Sharp 1.0 and 1.5, so we've grouped the 2 of them together here. We've listed all the important specifications here for both the 1.0 and 1.5 and the Sharp 2.0 XGA cameras. Now the key points here are that the Sharps have a context camera with a 320 by 240 resolution, and the Sharp is running on a Celeron 1 GHz processor and has 512 megabytes of RAM. As well, when we're looking at the lenses and illumination, we have several lenses ranging between 12mm and 50mm, with 3 different illuminations to handle the reflectivity of various license plates. Now, comparatively, when looking at the Sharp 2.0, we can now have a context camera with a resolution of up to 640 by 480, and we're now using an Atom 1.6 GHz processor, and the memory has been increased to 1 GB. The camera lenses have not changed since basically the available lenses already cover almost any situation, but the illumination has been upgraded and can now work in a completely dark environment. The reading distance on reflective plates has now increased to a range of 92 feet on the Sharp 2.0 cameras as well. Now, before going on to the software side of things, let's take a quick look at the hardware in the Sharp cameras. The first one we'll check out is the Sharp XGA, and this is the same layout for any version of the XGA model. The whole part here is the Sharp camera, contained in one unit. The main part is the SBC, or single board computer, which is our motherboard and the core of the system. Next to that is our video capture board, which is connected to our 2 cameras in front, the LPR and the context camera. The context camera is just a regular camera which is used to record a view of the plate that's being read as well as the vehicle environment around it. Also in front is our illumination board, which controls the LEDs used to make plates visible so they can be read with the LPR camera. External to the Sharp camera, we have a wheel camera, which records a view of the vehicle wheel to determine if the position of the vehicle has changed. This is a normal analog camera that is connected through the breakout box, or BOB. The breakout box is also responsible for providing power to the Sharp camera and to the wheel camera. We're going to see more on the breakout box in a minute there. So just to give you a few more details on the wheel camera, the analog feed coming from the wheel camera is processed by the Sharp. As mentioned, this is connected via the breakout box for power and to send the video feed to the Sharp. On the camera itself, you'll need to set up a special profile in the settings so it knows it has to process the wheel camera as well as its own cameras. Now, there is a restriction of one wheel camera per Sharp as well, but under normal circumstances there shouldn't be a need for more than that anyways. So just to give you an example of what the wheel camera would look like, we have a picture of one set up on one of our test vehicles here. And as you can see, the camera can be integrated with the vehicle, giving it a much lower profile. So moving on to the breakout box, we have the connectors to our two Sharp cameras on top here, using our proprietary cables. Between them is our power connector, which is going to the car battery. And then on the opposite side, we have our two network ports here, which are going to a laptop or other mobile data terminal. And last, we have our two analog BNC connectors here, which go to our wheel cameras, one of them per Sharp. Now moving on to the Sharp X, which was introduced earlier this year, we have made some significant advances in the hardware used. The Sharp camera itself is one of the smallest high-resolution LPR cameras on the market at the moment. We have increased the resolution of the LPR camera so we have a broader field of view. The illumination is 50% more powerful on the Sharp X camera compared to the Sharp 1.5. And on the processing unit, we're using an Atom processor, so there's improved performance. Additionally, there is one processor per camera, which we'll take a closer look at in the next slide. We also have better color on the Context cameras, and the cameras have more flexible mounting possibilities as well. As mentioned, the processing is not done on the cameras in the Sharp X system, so when we're talking about a Sharp X, we're referring to both the camera and the processing unit here that goes in the vehicle. So if we take a look at the processing unit, we can see that we have two single board computers and two digital signal processors here. That's one per camera, as well as the microprocessor unit. And these are all connected through switches that are accessible via LAN ports for your laptop or tablet. And we also have the camera interface ports here as well. Now this whole diagram here is contained in the main processing unit, which we usually refer to as the trunk unit because of its most common location. So now we'll take a look at the PRS, or Plate Reader Server, which is the main software running on the Sharp system that does the actual plate reading and processing. The PRS is image analysis software, which checks high-resolution infrared images to find license plates. In order to find license plates, the analysis is done based on a regional context in order to define what a license plate looks like. Simply put, different places have different looking plates, and we tell the PRS what rules to use in order to search for a plate based on the location. The Plate Reader Server creates a best read of the plate number by evaluating all of the infrared images it picked up of a particular plate. The output from the PRS is a cropped picture of the license plate in black and white, a context image of the vehicle, and any metadata information such as the GPS location and the time of the read. Now down here we can see a few examples of the plate images that are sent. This is based on what the LPR camera is actually seeing. Now let's take a look at the versions of the Plate Reader Server. These are all the current versions of the Plate Reader Server software for Sharp systems. The first thing to point out is that anything on or prior to version 4.3 SR2 is for use with the AutoView system. After that, we started using Security Center, so for example, the Plate Reader Server version 4.4 GA is compatible with Security Center 4.0 GA. So if we take a look at which versions of the Plate Reader Server software will run on which models of Sharp cameras and systems, There are a few important details to point out. As you can see, a Sharp XGA 1.0 camera can run on any version of the PRS software. We started supporting the Sharp 1.5 and Sharp EX, or blind Sharps, as of PRS version 4.2. The Sharp XGA 2.0 system is compatible with the last version of the AutoView PRS, excuse me, which is 4.3 SR2, and we started supporting it on the Security Center side as of version 4.4 SR1. The Sharp X system, which is our system with the smaller cameras in the trunk unit, is supported on version 4.4 SR1 and higher. So just a couple of quick notes on the hardware and software compatibility here. The Sharp XGA 1.0 and the Sharp X system do not support wheel imaging. This is something we're working on for the Sharp X, however, so you will see that in a future version. If you're running Security Center 4.0 GA, you'll need a cumulative package or a service release in order to use the Sharp XGA 2.0 and Sharp X. If you have ordered a Sharp camera for a particular system, the Sharp is installed and shipped with the appropriate version of the plate reader server software for use with the Genetec software it's being installed on. Now, to check which version of Sharp camera you have or happen to be looking at, the main thing to check is the PC name on the label. The label can be found under the lip, on the front of the Sharp, or on the back of the unit. If you need the PC name for the Sharp X, you can find that on the back of the trunk unit. Now, since there's two processors, you're going to have two PC names here. For the Sharp XGA models, if the PC name is between 1 and 403, it's a Sharp 1.0. If it's 404 and higher, it's a Sharp 1.5. And if the number starts with a 2, it's a Sharp 2.0. Similarly, the Sharp X PC names are defined as Sharp X with a number after that. Now, I'd just like to jump back to our PRS software timeline for a minute to take a look at some of the major features that were added in the various versions. Now, this is just a highlight list. If you want to know the full capabilities of the software for a particular version, I would recommend going to the GTAP and checking out the Documents section. So the Plate Reader Server version 4.1 was our first release and had the basic LPR functionalities in place. After that, we went to 4.2, which introduced wheel imaging and the support of the Sharp XGA 1.5. In 4.3, we started supporting Omnicast, and was the first version where you were able to define a region of interest. We were also able to recognize the state the plate came from, and we started supporting the Sharp 2.0. As of 4.4, we started supporting integration with Security Center, and supported the Sharp XGA 2.0 and Sharp X camera systems. In this version, we're able to configure the IP address within the software, so we don't need to set it up through Windows. We also introduced the gate read strategy, which we'll see more of in a minute, and made some improvements on the context and wheel image with the Sharp 2.0. Now, I'd just like to take a look at some of the key features for our newest release, the Plate Reader Server 5.0. These aren't new features, but just a general summary of what it can do. So first of all, we support both the Patroller and Security Center software. All the Sharp hardware configurations are supported, and we can set the network configuration from within the PRS software. We have 3 read strategies, which we'll see more in a minute, and support circling the plates in the context image, which is particularly handy when viewing a context image with multiple car lanes. We can specify a region of interest. We have a quick save feature, and we can also set the LPR regional settings to define how it will analyze the plates based on the location. Now, once again, this is just a summary of the features. You can find more details in the release notes on the GTAP. So if you've received a new Sharp and need to get it set up, let's take a look at the configuration that will need to be done. First of all, you'll need to open a remote desktop session to the Sharp camera. And once you're in, you can see the plate reader server icon in the system tray, as well as the watchdog here. PRS looks like a camera, and the watchdog is the same icon used in Omnicast, which is the little secret agent man. You can right-click on the PRS icon to pull up a menu with a few actions, like we've done here. If you need to see what the cameras are viewing on the Sharp, you can use the Show Live Feed, which will pull up a viewing window. When you're setting it up, I think you'll find you'll be taking a look at this quite often. For now, though, we'll want to start with the settings for the basic configuration. Now, all of our configuration will be done in the Settings menus. You can get to the settings from two specific folders. If you want to check the general settings, you need to run the autoview.settingsviewer.exe program from the d-autoview plate reader server folder. For tweaking or setting up specific settings related to the license plate recognition, you can also run the lpr.settingsviewer.exe from the d-autoview plate reader server lpr folder. Now, please note that there will most likely be backups of this software on the C drive as well, but the C drive is protected from any changes, and anything you do on there won't be saved. So you should be running these programs from the D drive. That's particularly important. Now, looking at the actual configuration, we need to consider what the system is supposed to be used for, either a fixed or a mobile system. They're not configured the same, so you need to know how the Sharp system will be used before starting to do the setup. In the configuration of the system, there is an extension setting, and you'll need to make sure this is set to the correct purpose of the Sharp system. You can find this in the plate reader section of the General Settings viewer. After that, you'll want to know, or basically select how the Sharp system will be used in specific. We can know it's a mobile system, but what kind of Sharps are we using, and what kind of hits will we be looking for? We do this through the config scope, which is in the same section as the extension type that we previously set up. One thing to note is that you can change the if you change the config scope, your current settings will be erased, so this would be one of the first things you'll want to set up. Now, there are a whole bunch of different config scopes in there, and each one has different parameters. So this would take a while to go over, so we're just going to go over a couple of examples today. One thing I'd like to mention, we're working on a document to go with this webinar, which will be posted on the GTAP soon. And in that document, we'll go into more detail on the different config scopes and what they can do. If you're setting up a Sharp for the first time and you're not sure which config scope to use, you can always give us a call as well. So taking a look at a couple of examples, we can see from these that they're for the Sharp 1.5, which can also be used for the Sharp 1.0 cameras as well. If you'll be checking plates against a set of hot lists, you'll want to use the first configuration here. If the purpose of the Sharp is to check parked cars to see if they've been there for longer than they are allowed, you'll want to use the overtime config scope. The main difference we can see between the two is that the overtime config scope supports the use of a wheel camera, which is used to verify the position of the car. If you try to use the Sharp 1.5 hotlist config scope when doing overtime checking, you won't have an option to view and record the wheel camera. There are many other options to support the type of Sharp system and use, including support for NTSC and PAL, and high-resolution context cameras. As I mentioned, that will all be covered in the document we'll have available on the Genetech Technical Assistance portal. The next configuration option we'll want to look at is the read strategy, or the plate reader server behavior. There are currently 3 read strategies: auto patrol, gate mode, and component info. The first option is used for mobile systems, so that's pretty straightforward. The other 2 can be used for a fixed camera, and the difference is in the vehicle behavior. Typically, the gate mode is used for any situation where the cars may stop in front of the camera, such as a parking booth or anywhere the entrance is managed by a guard or card system, for example. The component info is used for fixed systems in general, and is more likely used when cars are passing the cameras without stopping. One of the most common questions we get is whether the camera should be set to gate mode or the generic component info. So let's take a look at that with a real-world example. Taking a look at the Genetec campus here, we have a Sharp camera set up at the exit. So while we're setting this up, we need to ask ourselves which read strategy to use. In order to know that, we need to observe the behavior of the vehicles as they pass the camera. After some observation, we can see that most of the cars leaving the parking lot are stopping, either due to the local traffic or for the safety of the bikers or pedestrians. If we use the component info in this case, we'll get a lot of reads of the same vehicle as it is stopped for the bikers. So to correct this, we would switch it to gate mode, which would reduce the number of duplicate reads on the same plate. In the situation where we have a fixed camera set up on a highway, we would definitely want to use component info in order to read as many plates as possible. So just to summarize, component info is our fast and all-purpose read strategy, whereas gate mode is used in cases where we have slow or stopped vehicles. If you're not sure, the best course of action would be to use the component info, and if you're getting too many duplicates, then try to switch it over to the gate mode. Now, related to the reads and lens types, let's take a quick look at the live feed to see the information we get back from the camera. In our example here, we're looking at the context camera. The FPS, or frames per second here, is being given specifically for the context camera. If we change over to the LPR camera, we're going to get a different rate. Now, taking a look at the read information here, we have both the live read and the best read. The live read is the current plate that is being read from the system, whereas the best read is determined by processing several live reads with an algorithm to determine what is actually being seen. Since some of the live reads may not be useful and will be discarded, we don't bother counting the live reads, and instead we give a best read count. The best read is the information that is actually being sent to the patroller or security center, and the live reads are used for internal use by the Sharp. Now, one other thing we can see on the screen is the state. It's right there. If it has enough information, it may be able to determine the state the plate is from. In cases where the state information is not available or cannot be determined, you're just going to see a dash like this. Just to take a look at the actions available in the live feed, you can reset the best read count here. If you have set up a region of interest, this can be cleared. The quick save here is used to save a few seconds of LPR images, which is used more for troubleshooting. And you also have the hide and exit options here. Now, there's an important difference between the hide and the exit. Hide will minimize the window, and the plate reader server will still be running in the system tray. If you click on the exit, it will actually close the plate reader server program, so nothing will be read at that time. If your watchdog is running, it will bring it back up, but we don't recommend exiting the program. We mentioned the region of interest previously, so let's take a look at what this is and what it's used for. Basically, we want to prevent misreads due to external sources, such as fences, advertisements, and any vegetation that might be causing reading issues. We do this by reducing the field of view to a certain area. The area is defined by a series of points, and therefore it can be any shape. So if we take a look at our LPR image, you can see that we defined a region of interest around our top plate here. So this is the only one that will be read. Now this is something that should be used carefully so that you're not excluding plates that may need to be read. So let's go back to our Genetec campus fixed Sharp camera example. Here's our Sharp camera down here. If you take a look at it from another view, there's the Sharp here, the exit here that we were looking at. And what we want to do is capture only the plates of the vehicles that are exiting. We don't care who's coming in, we want to know who's leaving. But we have a couple of issues we have to deal with. First of all, we have buses that are passing right in front of the exit. We don't it won't pick up the plate since it's sideways, but in most cases it will see any text on the advertisements and try to resolve a plate from it. So if there's any text on here, this is a movie poster here, it's going to actually read that and feed that back, and if it detects any characters in there. Now also, this is not an exit only, it also serves as an entrance. So we don't want to read the plates of the incoming vehicles, only we want to get the outgoing ones here. But due to the wide angle of the lens we're using, it will pick up plates on the front of the cars as well. Looking across the street here, we can see that we also have some trees and poles, which may throw off the reading if it's seeing those as ones. So if we set up our region of interest, we'll be able to prevent seeing the text on the side of the bus. The trees won't be an issue here. And the only plates that we'll be seeing are those who are exiting the lot, and not the ones coming in from the incoming lane. The next thing I'd like to take a look at is the new capability to set up the IP configuration in the Sharp system. Originally, in the Sharp XGA versions 1.0 and 1.5, we had to set the network configuration in Windows. In the more recent versions, we're able to set this up in the General Settings viewer under the Net section here. You can set up the IP address, the mask, and the gateway, as well as the mode here. The modes are None, Static, or DHCP. You wouldn't want to use the None for obvious reasons. Static will let you specify all the settings above, and in DHCP it will search for a DHCP server and get an IP address from it on startup. Now if we take a look at the specific LPR settings viewer, we have another config scope field that can be set up under the LPR folder. This is used to optimize the reading process based on a particular state or country. If you're using the system in a location where you may be reading plates from many different states, you can use the generic US config scope. Some examples of locations where you may have many different states are at a university campus or a building located at the edge of a state. Now please note that if we make any change in the General Settings Viewer config scope, which was defining what type of Sharp system it is and what it'll be doing, this setting will be reset and you'll need to go back in and configure it again. Now before moving on from the configuration section, I'd like to just take a quick look at the default user that is accessing the operating system, which is the Gopher account. As of the Sharp XGA 2.0, we can now do everything with the Gopher user account as a local user and not as an administrator. So without having to have admin privileges, we can now install a hotfix, set the network configuration, change the plate reader server configuration, save pictures using the quick save, change the region of interest, modify the read strategy, and much, much more. Alright, so now that we've seen the configuration that's done on the Sharp camera system, let's have a look at the integration with the other Genetec software, specifically with Security Center. So taking a look at a fixed camera setup on a Security Center system, we started supporting this integration as of Security Center 4.0. The LPR camera and the context camera are added as two separate cameras. The Sharp can be auto-discovered on the same network, which will bring in your LPR camera, and the video feed can be brought in as a camera set up through an Omnicast federation or as a video unit in Security Center 5.0. We can also integrate a mobile system where the Sharp cameras are connected with the AutoView Patroller system. The configuration is done on the Patroller application, which can be integrated with Security Center. Let's take a look at how the various components on the system communicate with each other. Starting with a fixed system here, where the Sharp camera here is integrated with our Security Center over here. Our discovery is done on port 5000, which is being broadcast. If you're manually adding a camera, you don't need to worry about the discovery port. The live port is a one-way communication between the Sharp and the Security Center system, and is set up on TCP port 8731. Video command and control is done on HTTP port 80. And our WCF connection management and time synchronization is being done on port 8001. If you're having any problems with communication, the first thing to check would be that all of these ports are open. Now, just a quick note that we have a GSE mobile system connected to our Security Center system in the diagram here. Now, this is used for portable devices like Blackberries and iPads. But these devices will only be able to get the context camera feed from Security Center, so you won't actually be able to see the LPR camera feed through your GSE mobile applications. Now if we take a look at the mobile connection, we have our vehicle here with the AutoView Patroller application running it. And on top of the vehicle we have a Sharp camera in mobile mode. The live port is on TCP port 4545, and the time synchronization is on TCP port 4546. Time synchronization is not done on the camera, it's requested by the Sharp and sent from the server. Now on the other side of things, let's see how the Patroller connects to the Security Center system. The discovery is done on port 5000 again. And the WCF connection management is done on port 8001. The offloads are being done on TCP port 8731, but this information, as well as the hot list or user information, can be transferred using a USB drive as well. So taking a look at a complete system with both a fixed and mobile system integrated in Security Center, you can see it is the two components we just covered. And that's all going to the same system here. So what happens if we can't reach our Security Center system? Well, we have something in place for that, both in a fixed and mobile context. In fixed mode, the information is stored in a file called storeandforward.sdf. The amount of information that can be recorded is limited to the space available on the D drive of the Sharp system. If you have remoted into your Sharp, you can show live feed on the PlateRater server and then click on the extension details under the extension menu. From here you can see if the Sharp is offline and collecting records by the field circled here. If the camera is online, that value should be 0. Since we have 55, we know the unit is running in offline mode. On the mobile system, the data is being stored on the Patroller database. By default, we have set this to a 48-hour retention period, but this is configurable so you can change it if you like. Once the system reconnects to the Security Center system, it should transfer the information over. In the last part of the webinar today, I'd like to take a look at a few limitations and give you some support tips. Now, one of the problems you may see is that a system is not reading plates correctly. There are a few things that you'll want to check in order to track down the source of the problem, which we'll do a quick summary of first, and then we'll take a more detailed look in a minute there. So first is to check the read strategy to make sure it's set to the proper value for how the Sharp is being used. It's possible that the regional settings are incorrect or may need to be set up, which is the config scope value in the LPR settings viewer. Depending on the environment where the camera is installed, you may need to set up a region of interest in order to block out external factors that are giving false reads. The placement of the camera may also be an issue. The camera may be positioned in a way that is not able to read plates correctly. Also, you want to make sure that the lens that was installed on the Sharp is appropriate for how it's being used, and that the LPR camera can see the plates that are trying to be captured. If the field of view is too wide or too narrow, a new lens may be required. So let's take a look at the region of interest for a second. We have a few examples here of things that may be causing false reads, and that can be cut out using a region of interest. So starting with this example here, we can see some bushes that are in the shot, right up here, which may cause problems when they're moving with the wind blowing or anything like that. So what we can do, we can cut out a region of interest here, which will still pick up the plates that we need, but eliminate the bushes from the view. In our second example, we have a barrier, which may cause false reads if it bounces or shifts due to the reflectivity of the barrier. Using a very simple region of interest here, we have cut out the barrier and we're only taking the view above it into account. Now our third example shows a problem where we can see another lane here, but in our scenario we don't want to count the plates in that lane, only the main lane in the middle here. So what we can do is just cut out the lane here, and all the vehicles in this lane will be ignored. Now taking a look at the read strategy, this is under the Behavior folder of the Plate Reader General Settings viewer. This is where you would have to set it for a mobile or fixed environment, and if it's fixed, whether you would be using the gate read strategy or the component info. If you have it in gate mode, you can try it in component info and see if that helps, or vice versa. Now when looking at the problem with the lens or the position of the Sharp, we need to bear in mind that the lens for the context camera does not match the lens of the LPR camera. The context camera lens is 8mm by default, which gives a much broader view than any of the other 5 LPR lenses. For example, typically for mobile parking we have our default 8mm context lens, and we're using a 12mm or 16mm lens. So just to give you a visual example, here we have 2 live feeds from the same camera. The one on the left is the context camera, which is the 8mm lens, and the other one is the LPR camera using a 16mm lens. As you can see, the LPR camera is giving you a much closer shot of the plates, and the second plate on the left is not really even seen enough to get a read on it. That's this plate right here. So in terms of troubleshooting the position of the camera, you should be looking at the LPR camera to make sure it can see the plates you're trying to read. And in case you need to replace a Sharp camera in fixed mode in Security Center, there's a couple of things we need to pay attention to. Each Sharp camera gets a unique identifier, or GUID, based on the MAC address of the unit. So if you're putting a new Sharp on the system, as in the case of a replacement, it will have a new GUID. Because of this, Security Center will see it as a new camera, and will try to assign it a new license. The data that was collected with the old camera stays with the old camera, so it will still be accessible as long as we have the old camera still in the system. If you delete the old camera, you'll free up the license, but lose the data you had associated with it. At the moment, we don't have a way to merge the data from the old Sharp camera and the new one, so if you need the data that was on the old unit, you'll have to keep it on the system and call us to get a new license for the replacement camera. One other problem you may see is a connection issue with the Sharp camera. The first thing to check would be the firewall to make sure it's not blocking access to the camera. You'll want to check the ports we outlined previously to make sure they're all open on the network. If you make any changes to the default ports we have listed, you'll want to make sure that the changes are applied to both the server and the plate reader server or mobile application. If you're using multiple LPR managers in your system, we have a very detailed knowledge base article on the GTAP about this. You can take a look at KB number 641 to see how this can be configured and where the ports need to be changed. A quick tip is to run netstat -n on the Sharp camera. If the connection says established in the report that comes up, then you don't have any problems and the Sharp is connected. In the Show Live Feed window of the plate reader server, you can take a look at the extension details to check on the state of the Sharp as well. Video stream 1 is the context stream that's going through, and the gateway connection 1 is the LPR camera stream. Also, as we had mentioned, if you're seeing any records in the database, it means that your Sharp is running offline and storing the data locally. This is under the number of records in the database field here. So checking the ports, you'll likely see that port 8001 is being blocked, but port 8731 is fine. You can see this by running the netstat -n command. Now that's the other thing here. You'll actually see that it says connected. You'll see the local reads, but you'll see the connection state is connected. So that's when you want to check the netstat -n there. Now in some cases you may want to check the full version of the plate reader server that you're running. If you're troubleshooting an issue with the Genetec Technical Assistance Center, we may require this information in order to see if there are any hotfixes for that version that might be applicable. The way to check the file version is through the Windows Explorer. Once you go to your D AutoView Plate Reader Server folder, you can add a column in Windows Explorer that will allow you to see the file versions. As you can see in this example, we have version 4.0.394.0. Now, one last thing I'd like to do is give you a peek at what we're working on, and will be available in future releases. We are looking at centralizing the management of the Sharp system through Security Center, so you won't have to make changes or configuration settings on two systems. Another idea that's being explored is being able to remotely push hotfixes and version upgrades to the Sharp cameras from the server. And last, similar to what we've done with the Server Admin in Security Center 5, we're working on a web interface for the management and configuration of the system. Now at the moment, I don't have a time frame for these changes, but keep an eye on the GTAP for any new releases. And that's the end of our troubleshooting section, and also concludes the webinar for today. If you have any questions you'd like to ask, we're going to keep the webinar open for another 10 minutes, so please go ahead and type them in the questions box of the GoToWebinar console. If you think of any other questions once the webinar session has ended, you can always post them on the GTAP forums under the GTAC Tech Talk section. Any comments or feedback on today's webinar or the GTAC Tech Talk series in general are always appreciated and can also be left on the GTAP forums. On behalf of myself and the Genetec Technical Assistance Center, thank you very much for attending today's webinar, and we hope you all have a great day.